right, set 4. Complex fractions. So even with the word complex and you're thinking, oh no, they're harder, they're not. Don't get too caught up in that. Hopefully I'm going to break it down so it's simple enough for you. But complex fractions just means that there's fractions within fractions. So we're going to look at about 6 different examples here. They do take up a lot of space. Even though themselves are not that difficult, they do take up a lot of space. Do not try to cram these in a little spot. Use paper. Write things out big and large so that you can see them and follow them. Because the reason people make mistakes is because you try cramming stuff together and you can't follow your own work. So let's start with x over 2 minus 5 all over 6 plus 3 over x. Now, the way that I show these and that I expect you to do them is when you see the big fraction bar, rewrite the problem horizontally. Write it out, numerator first, because you read it first, it goes first. Big divide sign, because that's the fraction bar, and then the denominator. Now, deal with one side at a time. Only deal with the left side, or the numerator. Alright, so all we care about is the x over 2 minus 5. Well, at this point, you should go, okay, that's over 1. So the common denominator is 2, which means the first one stays and the second one becomes 10. So we get x minus 10 over 2. No problems. Alright. Now we go to the second side. 6 plus 3 over x. Put the 6 over 1 so that we know the common denominator is x. That means the first one needs an x and the second one stays. So we get 6 plus 3 over x. All with the big divide. But we already know how to do division. We know division is really multiplication of reciprocals. So all I have to do is multiply and reciprocate. Now I can look to factor, see if that helps me any. And I can factor the numerator or the denominator of the second one with a 3. And we find out, not so much. When I put this together, nothing cancels, nothing's alike, so I just leave x minus 10 and x. I can combine the 2 and the 3, they are numbers, so I can get 6 and x plus 2, but that's it. There's nothing else I can do. I cannot reduce anything, combine anything, factor anything. It is what it is. However, when you're doing these problems, they do take up space. Each step by itself is not a difficult step, but you do need to show them. You do need to break it out, separate them apart, and show all the steps. So here I have 20 over x plus 1, and I'm going to divide that by 1/4 minus 7 over x plus 1. So I'm going to first start by writing the numerator, big divide sign, so I know that is the numerator, and the denominator. Now I'm going to deal with one side at a time. Well, 20 over x plus 1, there's nothing I can do. Can't factor it, can't reduce it. It's not separated, so I don't need to combine it. It already is. So I get to move on. Come over here to the other side. 4 and x minus 1. Well, each piece needs to be part of my denominator. The left-hand side is missing the x plus 1. The right-hand side is missing the 4. So I get x plus 1, 28. So I get x plus 1, I get x minus 27 all over 4 and x plus 1. Big divide and 20 over x plus 1. Now I multiply by the reciprocal. The x plus 1's cancel. 20 and 4 gets multiplied together, and the x minus 27 stays. All right, try it again. Each time we'll make them a little bit more difficult here. So we got 1 over 4x plus 3 minus 5 over 3. 4x plus 3. All over. So big fraction bar there. So what that means is when I write this, I'm going to write it going across. And you can do the same thing. When it comes to your homework, instead of rewriting the problem twice, you can put your numerator, big divide, and then your denominator. You don't need to rewrite the problem twice. All right, so if I'm over here on the left-hand side, I need a 3 and a 4x plus 3. So that means the first one's missing a 3. So I get 3 and 5, so I get minus 2. On the right-hand side, it's already combined, don't need to do anything, so I'm just going to multiply by the reciprocal. Now I get to cancel out things that are alike. Left over, negative 2 over 3x. It starts off as really big and ugly, turns out to be very tiny and small. Okay. 1 over x minus x over x negative 1 plus 1. Big divide. Again, just so we don't have to keep writing things out, I'm going to put a big divide and then 3 over x. Now, I need to deal with this. What is x over negative 1 mean? Well, a negative exponent means cross the line, change the sign. Right? X negative, it means it's going to become a fraction. It doesn't cross this line. It can't because of this plus 1. Because remember, all of this is together. So it still has to stay down here. But what it does do is that it creates another fraction within a fraction. So I have 1 over x minus x divide 1 over x plus 1. I need to take care of this first. So here I have 1 over x, that's nothing. This x, I can't do anything with it because I have to take care of this right side of the division. So the common denominator is x. So I get x divided by 1 plus x over x. Now I get x times x over 1 plus x, which is x squared over 1 plus x. I have to do one thing at a time. Everything has to be made into one fraction. Fortunately, I mean, this was one fraction we didn't have to worry about. This was one fraction we don't have to worry about. This was not. So I had to take care of it. I have to take care of it and keep going until it is just one fraction. Now I have to make it into one fraction. I've got to keep going. So the one fraction is going to be x and 1 plus 1, 1 plus x. Okay, this one is missing the 1 plus x, so there it is. and this one is missing the x. I'm going to come up over here to the side. So here I'm going to get negative x cubed plus x plus 1 all over x and x plus 1 divided by 3 over x. Well, that's a reciprocal. Which reduces. So I get negative x cubed plus x plus 1 all over 3 and x plus 1. This does not factor. It's a cube, therefore it has to be a grouping or it has to be a perfect cube, and it's neither one of those. So there's my final solution. Really, all the work happened with that 1, because that was an easy combine x and x plus 1. And then this one didn't need any. Okay. I told you they take up a lot of paper. And that's just the way it is. So make sure you have a good stack and supply available. 4 x squared minus 9 plus 2 x minus 3. Big divide, because this is going to be my fraction here. But I'm going to move it up so that it's 1 over x plus 3 and 1 over x minus 3. Okay, so all of this was below here for a fraction. Fraction within a fraction. But put the big divide, rewrite it horizontally. Don't rewrite the problem twice. Alright, so now I have to combine those. Well, in order to combine those, I first need to factor. I need to know that this factors into a difference of 2 squares. One of the pieces is already alike, so this second one is only missing the x plus 3. So I get 4 plus 2x plus 6 all over x plus 3, x minus 3, which is 2x plus 10. And if you wanted to even go farther, you could say that's 2 and x plus 5. I don't know if that'll help us, but we always want to consider it. Alright, the other side needs one of each. So we have x plus 3 and x minus 3. First one's missing an x minus 3. The second one is missing an x plus 3. So we get x minus 3 plus x plus 3. So we're going to get 2x over x plus 3 and x minus 3. Remember, that's a big divide. So now we're multiplying by reciprocal. X plus 3, x minus 3 all over 2x. Now look to cancel things out. Plus 3 minus 3, 2 and 2. Left over x plus 5 over x. In and of itself, each one is not a difficult process. But if you look at the whole problem, it's overwhelming. So don't look at the whole problem. Simply look at the one piece at a time. Okay, I got to factor this. All right, now I got common denominators. Okay, good. Done. Then come over here. Then come to the multiply by reciprocals and cancel things. Do it piece by piece. All right, last one. Try it on your own, meaning pause the video and then come back and I will work it out. We have 2x squared plus 6x plus 18, x over x cubed minus 27. Big fraction, which means big divide sign. And then the denominator, 5, 3x minus 9, 3 over x minus 3. Remember these big divide signs to rewrite them. And then put the denominator to the other side. Alright, pause the video and then come back. Alright, you should have gotten that this had a GCF, so it would have factored to x squared 3x plus 9. Nothing multiplies by 9 and adds to be 3, so that's as far as it can go. This is a perfect cubes of x and 3, so you should have got x minus 3, and then x squared plus 3x plus 9. Ooh, that's nice. They're the same, which 99% of the time that's going to happen. So that the common denominator is 2, x minus 3, x squared plus 3x plus 9. Now on this first one, it's missing the x minus 3. And on the second one, it's missing the 2. So we're going to get 3x minus 9 plus 2x for a total of 5x minus 9 all over that common denominator. Now on the right-hand side, if I factor out a 3, I get x minus 3. That's good. So that the common denominator is 3 and x minus 3. The second one is only missing the 3. So we get 5 minus 9 for a negative 4. Multiply by reciprocal. And we're going to look to reduce stuff out. So x minus 3 is going to cancel x minus 3. And that's it. So here we have 3 and 5x minus 9. Negative 8. And x squared plus 3x plus 9. And there you go. That is set 4, complex fractions.